In our previous lessons, we were working on graphing your quadratic equations, whether they were written in vertex form, factored form, or standard form if we could put them into a factored form. So we'll review all these again today and do some more practice to get ready for the upcoming assessment. So this video will focus on these problems, and so you can go along with your notes or on Class Kick and fill in as we go. So if we look, 9 and 10 are using the same graph, and based on a graph, you should be able to write the equation in both factored form and vertex form. So let's give you a moment here. We've got our graph, and number 9 is asking for the factored form. So we know whenever we have a factored form, the most important key feature of that graph for us are going to be the x-intercepts. So I want to locate that. Where is it crossing or touching the x-axis? And for us, it's these two locations. And that would be at -4, 0, and 2, 0. So again, we're thinking, okay, well, if I ended up with an x value of 4, if x equals -4, where did that come from for my factor? If x equals 2, where did that come from for my factor? And so my factors think about undoing, you have a +4 and a -2. So the other thing you want to think about is concavity, right? Because that's going to tell you what kind of a value to anticipate for the equation. Because this is concave down, we know it's been reflected over the x-axis. My a value should be negative. So when I'm looking at the x-intercepts and knowing my a value has to be negative, I have to go with my answer for a. Now for 10, it's saying what's the equation in vertex form? So again, we want to think about concavity. We know it's concave down, so a has to be negative, and we want to find the vertex for our graph. And so my vertex is at -1, 9, meaning it moved to the left 1 and up 9. So which equation would show both of those things? That would be C. I can see the concavity in front being negative, going to the left 1 and up 9 for my equation. So we're going to use those techniques to help us with our graphing. We look at number 4. This equation is written in standard form. So if it's in standard form, we want to try to put it into the factored form so we can start getting the graph going with those x-intercepts. So a lot of you still like going back to the idea of the box to help you with factoring. Remember that first term is going to go on the top left. The last term is going to go on the bottom right, as long as it's in standard form. And so we're thinking about two numbers we can multiply together to get 21, but add to give us the -10x. And x squared we know comes from x times x. So a lot of you are probably getting pulled towards 7 and 3 for the 21. They both would have to be negative to multiply to get the +21. And then they both have to be negative, so I add them to get the -10x. So to get my x-intercepts, we're going to think about setting each of those factors equal to 0 to get the values of x. Excuse me. So x-intercept is going to be at 3, 0, and 7, 0. So I can put those on my graph to get that going. Now, remember, these are mirror images of each other, so we have to find in between 3, 0, and 7, 0, because that would represent the mirror, the axis of symmetry. And so that's going to happen at x equals 5. Now, the axis symmetry goes through the vertex. We have the x value for the vertex. We just need to solve for the y value. So what I can do is take the value for x and either put it into the original equation or my factored form to see what value of y comes with it. I'm going to go to the factored form route and think about 5 minus 7, that's -2, 5 minus 3, that's +2, multiply them together, I get my -4. So I have my x-intercepts, I have my vertex, I have my axis symmetry, the mirror. All I need to do is get a couple other data points and reflect them over that mirror to help me complete my graph. So if I think about my table, here's my mirror, right? The vertex axis symmetry. Here is my one x-intercept, here's the other. I'm going to pick values on either side of the mirror and the x-intercepts to help me. So maybe I want to go with 4 and 6. Maybe I want to go with 2 and 8. Maybe I want to go 1 and 9, 0 and 10. That's up to you. But remember, whatever you're picking for your x values, you're going to substitute them into either the original equation or your factor form to see what you get out for the y. These are the outputs for my selected inputs. And again, you can see the vertex, the mirror, the symmetry that's happening in your table. And that's giving me plenty of values, or I should not say values, points to plot to get the parabola formed. Now, when you think about the equation piece that we did on last numbers for 9 and 10, the leading coefficient is 1, it's positive. So we should have known it was concave up, and we can see that in our graph. We can also see it in our table. What else? We've got the x-intercepts. We talked about concavity. If I want to do the y-intercept, I know it's going to happen someplace here, so I need to take 0 and put it into my function and do a quick calculation. So if I put 0 here and here, -7 times -3, that would be a positive 21. Domain, we know, doesn't change for any of your quadratics. We talked about how this is concave up, and the range, because it's concave up, our lowest we can go is the y value for the vertex. We have that limitation at -4, and that will continue on to positive infinity. So we have our bracket around -4, parentheses, whenever we have infinity symbols. Now this equation is in vertex form. So it's nice because we know the transformations. That will tell us the vertex. It will also tell us the concavity. It will also tell us if it's going to be wider or narrow because that a value. And so if I look at my equation, the first thing I see is the negative, which means it's concave down. It's been reflected over the x-axis. Also, 1/4 means it's a shrink, right? It should be 1/4 is fast, so it's going to be a wider parabola this time. The next part, the -1, tells me I'm going to go to the right 1 unit, and the +4 means I'm going to go up 4 units. Now, going right up 4, that's giving me the clue of the vertex. And we talked about the concavity already being down because of that reflection to start with. Because I have the vertex, remember you could draw on your axis of symmetry, the mirror, and that happens when x is equal to 1. We are going to build around that in our table. So we want to pick values to the left of 1 and to the right of 1. And substitute those values into our function, our equation. You might also want to pick, as you're deciding on what values to select, it could be any ones that you choose. It's a good choice to also select an input of 0 because that would tell you your y-intercept. And whatever x values you're choosing, you're just putting them into your pattern and doing your quick calculation. So, based on the ones that I have selected here, they're showing up in black. Here are the corresponding outputs. If you selected the 0 for the y-intercept, you found out that its output was 3.75. So again, we're checking the table. I can see the symmetry. I have 4 or 5 more points I can add to my graph and connect them to make my parabola. Now in terms of x-intercepts, I'm looking to see where it touches or crosses the x-axis. I can see those 2 points here. I also can tell in the table because the output here is at 0. So my x-intercepts are at -3, 0, and 5, 0. Domain, we know never changes for your parabolas, your quadratics, always -infinity to positive infinity. And the range, because it's concave down, remember we're going lowest to highest, it's going to keep decreasing. So we have no limit for that lowest end. So I have a -infinity to start, And the highest it can go is going to be the y value for the vertex at 4, so I have my bracket. All right, we'll take a look at one more. If I look at this equation here, I can see it's in that vertex transformation format. Sort of think about what it's telling us so we can get that graph going. So again, we're just going to kind of work our way from the left to the right. So I see that negative. It's telling me that it's concave down. I also see the 2, which means it's 2 times faster than it was before. So it's going to be narrow. So a vertical stretch of 2. The plus 5 inside the parentheses, saying I'm going to the left 5 units. And at the back, that minus 3 says I'm going down 3 units. Remember, left 5, down 3, I have my vertex for my parabola. And if I have the vertex, that gives me the clue about my mirror, my axis of symmetry, being at x equals -5. Now we're going to look at 2 inputs to the left and right of -5. So what's happening at -6, 7, 8, and so on. What's happening to the right? -4, 3, 2, 1, and so on. Whatever you are selecting for the x values, you are going to substitute that into your function and do a quick calculation to see what we get out. So these are the outputs for the inputs I selected. And again, with the mirror for the vertex, we should see the symmetry in the table. So if I plot those data points and it's concave down, I have the formation of my parabola. Because I moved it away down, away from the x-axis, I have no x-intercept, so we're going to write none. The y-intercept, where it crosses the y-axis, I know that will happen someplace down here. So another quick calculation, substitute the input of 0 into for x and see what we get out. So 0 is just going in here. And when we do that, it's going to be -53. Domain never changes for your parabolas, all real numbers, -infinity to +infinity. And the range, again, we've got to be careful, lowest to highest, because it's concave down. There's no limit to how low, so we need the -infinity to start with our parentheses, all the way up to the y value for your vertex, which is at -3. And so we need the bracket because it's as high as we can go. So that was our quick review on graphing your quadratic functions, whether they're written in the vertex form like this one, whether it's in factored form, or if we need to put it into factored form to solve, to get the graph going, I should say, and also how we can use the key features like the vertex and the x-intercepts to write equations for our parabolas.